5 cosine squared of theta plus cosine of theta is equal to 0. Because cosine there is squared, that obviously means we are dealing here with a quadratic equation. So we can use factorization. You will notice cosine of theta is common. So let's factorize. We can take cos theta outside. Then we get 5 cosine of theta in here plus 1. All that is equal to 0. Right, then you get your two equations. One is cos theta is equal to 0, or 5 cosine of theta plus 1 is equal to 0. So these are the two equations that we get. And now we need to solve these separately for theta. Let's start with cosine of theta is equal to 0. Do you think that will give us boundary angles? Okay. Remember, we said the graph of cosine theta looks something like this. That's 360 degrees there. It's 90 degrees here. How many degrees is it there? 270, right? So this is 270 degrees. Okay, so looking at this graph, we need to get an answer of 0 for whatever value of theta we pick. So what is the first obvious value of theta there? So 90 degrees, right? So if you know that cosine of 90 is equal to 0, you don't even have to draw that diagram. You just need to know that cosine of 90 is equal to 0, which means one of your angles should be 90 degrees. But we can add many more revolutions here. So let's do that. Plus k 360 degrees, where k is an integer. And from your graph there, the other value is obviously 270 degrees. I'll show you the quick way of doing this right now. So that's 270 degrees plus as many revolutions as possible. Okay. So these are the two general solutions from cosine of theta is equal to 0. Maybe one lesson that we can learn from this, please compare these two here. If one of the angles is 90 degrees, then there should be another one which is 360 minus 90 degrees. So let's generalize. If cosine of x is equal to a, then number 1, x will be equal to arc cosine of a. That is one of the angles, right? That's shift cosine of a, obviously plus k 360, plus k 360, where k is an integer. But that won't be all. So let's say or, number 2, x will be 360 degrees, subtract that angle, shift cosine of a. So subtract arc cosine of a, right? So that's another angle. So one of the angles was shift cos a. Then the other angle should be 360 subtract shift cosine of a. Obviously, to this angle also, you are free to add as many 360s as you want. The other equation is 5 cosine of theta plus 1 is equal to 0. So let's make cosine of theta the subject. So cosine of theta should become negative 1 over 5. What is the reference angle? Sorry, it's 100 and? No, a reference angle should be acute. 78, yeah, let's make it 2 decimals. 78,46 degrees. Remember, the reference angle should be positive, so ignore the minus sign for now. Okay, and then draw your reference angle in its proper place. Your reference angle is in the first quadrant. So that is 78.46 degrees. But cosine of theta here is negative. So where should we get our theta from? From quadrant 2 and quadrant 3. Okay. So if we continue using the reference angle method, then this angle here is 78.46. Okay, that is 78.46. So from quadrant 2, give me that angle. 101.54. Okay, right. Now you can add K360 there. You can add K360. So that is from quad 2. Then from quad 3, this is what we have, and this is 78.46. So we are looking for that angle there. So from quad 3, what is theta? You said 180 plus 78.46, right? And you're getting? 258.46. And you can add as many 360s as you want. Sine x minus 6 sine squared x is equal to 0. We're solving that for the general solution. So we can factorize straight away. Sine x is common, right? So sine x is common. And we get 1 subtract 6 sine x in the bracket. All that is equal to 0. Then your two equations now. The first one is sine x is equal to 0. The other one is 1 minus 6 sine x is equal to 0. So we are looking for sine x equal to 0. It is 0 here at 0. It is also 0 there at 180. So clearly, one of the values of x must be 0 degrees. But if I add as many 360s as I want, right, you will notice this then takes care of the 360 degrees. So if I put k equal to 1, I will get another angle as 360 degrees. And I can continue like that. But do you see that 180 is not covered by this statement? There is no value of k that we can find which will make x equal to 180, right? Do you agree? So we need to then remember that 180 should also be there. So 180 degrees is definitely one of them. And it is not the only one. There are so many other angles that were not taken care of in the first equation. So to 180 degrees, then we need to continue adding 360s because the period for sine is 360. Okay, so this is what we end up with. Right, so the other equation is 1 minus 6 sine x is equal to 0. If you rearrange that, you should get 6 sine of x is equal to 1. Now let's continue. The reference angle? Shift sine of 1 over 6. What did you get? 9.59 degrees. Okay. Right. That is the reference angle. Then I think somewhere you will want to draw your reference angle somewhere in the first quadrant. But where are our answers? Sine x is 1 over 6, so it's positive. So it's in quadrant 1 and quadrant 2. Right. Now let's start from quad 1. So from quad 1, we're measuring from 0 degrees. How many degrees is that? So that means x is equal to 9.59 degrees. But we can add many more revolutions, right? So it's plus k, 360 degrees. K is an element of the integers, all right. Right, that is quadrant 1. Then in quadrant 2, remember this angle now is 9.59. So how many degrees is all that? 170.41. Okay. 170.41 plus K360, where K is an integer. Right, sine x is equal to 2 cosine of x. Now, the ratios are different. That is sine, that is cosine. Let's divide both sides. Divide both sides by cosine x. We are assuming that cosine x is not equal to 0 here. Otherwise, that is not allowed. The left-hand side, you see, becomes tan, right? And the right-hand side becomes 2. You can find your reference angle now. What is the reference angle? Shift tan 2 in your calculator. 63,43 degrees. Okay, good. Then, in terms of quadrants, where are we getting our angles from? So this is 63,43. So we're getting that from 1 and 3. Okay, so from quad 1, what is x equal to? 63,43 degrees plus k 360 degrees, where k is an integer. That will be all. But from quadrant 3, remember that line is extended like that, and this is 63,43. So we are looking for that angle there.
180 plus.
So yes, it's 180 plus 63,43. What do you get? 200 and comma 43. 43. Okay, plus k 360, where k is an integer.